Okay, what is the pH scale? Basically, the pH scale is a scientific scale used to measure the acidity and basicity that which we kind the alkalinity of an aqueous solutions. It is based on the concentration of hydrogen ions present in the solution. So the pH stand for potential of the hydrogen. The pH scale range is a logarithmic scale from 0 to 40 that measure a substance's acidity or basicity, which we call alkalinity, with 7 being neutral. So below the 7 being acidic and above the 7 being the basic, where each whole number represent a rainfall change in acid and base. For example, pH 4 is 10x more acidic than pH 5, while typically 0 to 14 extremely concentrated solutions can go below 0 and above 14. But the standard range cover most applications from strong acids like battery acids to strong base like drain cleaner. There is a scale elaboration like pH scale is back time measurements tools that determine how acid and base, which we call alkaline to water based substances, using a numerical range from 0 to 14. A pH value is measure of the concentration of free hydrogen atoms in a solution. The scale is logarithmic, meaning each whole number change represents a difference in acidity or base. There is the breakdown of the pH scale. For example, the scale is divided into three main categories. The acidic pH, which is less than 7, the value below the 7 indicate in acidic solutions. The lower the number, the standard the acids. For example, there is the pH 7 and other neutral pH, which is the 7, while basic or alkaline pH, which is greater than the 7 solutions. So there is some neutral substances like substances is material or compounds that occur in natural organism from plants, animals, or minerals and exist without the significant human manufacturing. So the acidic substances is a chemical that donate the proton hydrogen ion in water, taste sour, feel stingy, turn blue litmus paper into red, and has a pH less than 7, indicating a high concentration of the hydrogen ions. A basic substances, which is the bases, are chemicals that accept the proton, which is the hydrogen ions, or release the hydroxide ions, have a pH above the 7, which taste bitter, feel slippery, and turn a red litmus paper into the blue, commonly used in the cleaner and antacids to neutralize the acids. There is a strong acids is in acids that completely ionized in water. It releases a high concentration of hydrogen ion in solution. There are some weak acids in acids that does not completely ionized in water. It produces a limited number of hydrogen ions in the solution. Because of partial ionization, the weak acid show the mild acidic behavior. There is some strong bases. For example, a strong base is a base that completely ionized in water. It produces the large number of the hydroxide ion in solutions. Because of complete ionization, the strong bases show the strong basic behavior. There is some weak bases. For example, a weak base is a base that does not completely ionized in water. It produces a limited number of hydroxide ions in the solutions. Because of partial ionization, the weak base show the mild basic behavior. There is some importance of the pH. For example, the pH is important because it shows the whether a solution is acidic, neutral, or basic. It helps to maintain the right conditions in living organisms, soil, and the water. It control the pH is also essential for industrial processes, food, and the medicines. So pH play an important role in the daily life. For example, pH affects many everyday things we use and consume. For example, the water, safe drinking water should have a neutral pH, which is the 7. The food, such as the citrus foods, are acidic, while baking soda is basic. Some cleaning products like soap and detergents are usually basics to remove the dirt. Some skin cares like lotion and creams are formulated with specific pH to protect the skin. So in short, the pH help keep our daily life balanced and healthy. There is the pH of the common acids. For example, the pH of a solution tell us how the acidic it is. Acids always have pH values less than 5. So the lower the pH, the stronger the acids. There is some lemon juice has a pH of about 2 to 3, which make it mildly strong acidic. Some vinegar has a pH of about 3, so it is also acidic but not as strong as human lemon juice. Some stomach acids like hydrochloric acids in our stomach has a pH of 1 to 2, making it very strong acids. So a key point, a lower pH more acidic and a higher pH is the less acidic. There is some pH of the common bases, like common bases have pH value greater than 7 depending on their strength. For example, baking soda has a pH of 8 to 9 and a soap solution has pH of 9 to 10. So stronger bases like caustic soda, sodium hydroxide have a pH 13 to 14. So as explanation, bases release the hydroxides ion in the water which make the solution alkaline. The higher the pH above the 7, the stronger the base. So the mild bases like baking soda or milk of the manganese are safe to use. There is some strong bases like caustic soda or ammonia are very corrosive and must be handled carefully. The pH scale common chemicals like pH 1 is the stomach acid which is hydrochloric acid, pH 2 to 3 is the lemon juice, pH 3 is the vinegar, pH 5 is the rainwater, pH 7 is the pure water which is the neutral, pH 8 to 9 is the baking soda solution, pH 9 to soap solution, pH 11 to ammonia solution, and pH 13 to 14 is the caustic soda which is the sodium hydroxides. The pH scale of the common acids include the pH 1 to 2 is the hydrochloric acid which is the stomach acid, sulfuric acid, pH 2 to 3 which is the lemon juice which is the citric acids, pH 3 is the vinegar which is the acetic acid, pH 3 to 4 is the orange juices, and pH 4 to 5 is the carbonic acid which is the soft drink. So the pH scale common bases such as the pH 1 to 2 is the stomach acid and battery acids, pH 3 to 4 is the lemon juice and vinegar, pH 5 to 6 is the coffee and rainwater, pH 7 is the pure water which is neutral, pH 8 to 9 is the baking soda and the sea water, pH 8 to 10 is the milk of magnesia and soil soft solutions, and pH 12 to 14 is ammonia, caustic soda which is sodium hydroxides. So the benefit of the pH scale is it helps to identify whether a substance is acidic, neutral, or basic. It is widely used in chemical and laboratory analysis. It helps to maintain the safe drinking water quality. It is important for a soil testing and agriculture, and it helps to understand the biological processes in the human body. So this is all about the pH scale and how it is useful in our daily life.